Let me begin this video by giving you a reason for using hashing in DBMS. In DBMS, we always have a data structure called indices, and it helps you to find the data that you're looking for within a database. So indices work just like an index in a textbook. If you have a textbook and you want to go and search for a topic like SQL joins, you know that it would be available in a chapter called SQL. So you'll just go to your textbook index and you'll find out where SQL is. And then within that chapter, you'll look for SQL joins. And you'll get a page number and you can just then go to that page number. So if you do not have an index, you have to search each and every page till you find your topic, and sometimes it's even possible that the topic you're looking for is not even present in the book, in which case you'll just end up turning all the pages and still not find your topic. In DBMS also, this type of data structure is available. So indices give you the location in your hard drive for some record. So every record in your table, and by record I mean every tuple in your table is stored in the hard drive, and whenever you want to work with it or you want to access it, you have to fetch it from the hard drive into the main memory, and only then you can work with it. So to do this fetching process, you need the address, the exact location in the hard drive of that tuple that you're looking for. And this work is done by the index. But once again, you need to know what you're looking for. Just like when I want to search for SQL joins in a textbook, I need to know that I'm looking for SQL joins, and only then I can go and search for it. Same way, you need to know what you're looking for within the database. So as you can see on your screen right here, there's a table, and this table contains details about instructors. So if you are looking for some instructor using the ID of the instructor, then you can search the index directly. There's always an index created on the primary key of the table, and obviously ID would be the primary key of this type of table. So what you have to do is you just need to write a simple query, and then your software just fetches it for you. Now this software is going to first look in the index to see where it can find that particular ID that you're looking for, and then it sees the address and visits the hard drive to that particular location and fetches the data for you. That's how an index works. But that's a single level index. There are several types of indices in DBMS. There are multi-level indices, and there are also hashed indices. Hashed indices are much faster to access than a simple index, because in a simple index, you just have to start from the first record and you just go 1, 2, 3, 4. You keep on moving till you find the record that you're looking for. But if you had a hashed index, you just apply a function to the value that you have to search, and then you get a key which is like an address in the index. So there's an address in the index also, and then you visit that address in the index and find the address in the hard drive and fetch the data. So that's how hashing makes things faster, and when I explain an example of that, you will understand it better. So let's just move on to the example. In order to perform hashing, there are certain requirements, certain things that you need. And one such thing is the hash table. So the hash table is of a specific size, and depending on the type of data you want to store and the number of records you want to store, you will decide the size of your hash table. What you can see on your screen is a hash table, and that hash table is of size 10. But that doesn't mean you need a hash table of size 10 always. In practice, you'd require a hash table that's a lot larger. But for the purpose of examples and for the purpose of simplification, I'm going to use a hash table of size 10 for all the examples that I'll be explaining in this video. This hash table also is of size 10, and you can see that there are indices. So there's an index which goes from 0 to 9, okay? And then there's a space, there's an empty space. And this empty space is there for you to store the actual values of the record. So that's what a hash table looks like. Now, once you have the hash table ready, the next thing you need are keys. So you require keys to be inserted. These are the values. So in the previous part of the video, I explained to you that there are IDs of instructors. Now, those were really large numbers, but obviously I'm not going to use such large numbers in order to explain to you what hashing is. So we're just going to use some 2-digit IDs, which you can see. So all these keys, you can consider that they are 2-digit IDs that I need to save as an index so that I can access them very quickly afterwards. So these keys are the IDs, and they are not just numbers, they can be alphabets also. So for example, if you want to create a hash table or a hash index using the names of instructors, then in that case you would be using the hash table with alphabets instead of using it with numbers. And this also can be done because every character in the alphabet can be converted into a number by using the ASCII values. So after doing that, you can always have a fixed number that you can apply a calculation or function to. Which brings us to the next thing required in hashing. It is called a hash function. A hash function is sort of an equation, or you can say a formula, that allows you to apply hashing on the keys that you have. So you already have certain number of keys, and now you want to apply hashing to those and save them in a hash table. So you require a formula for this, and this formula will allow you to get the exact index for a particular key, and then you'll put that key in that index. So when you apply a hash function to a key, as an answer, you get an index, and you will store that key in that index position. When you want to search for the same key now, all you need to do is apply the hash function, and whatever answer you get, whatever value you get, that would be the position at which that key is inserted. So you see, it saves a lot of your time, because not your time obviously, the software's time, the software that's giving you the data. So the time is saved because you are looking at the instead of looking in a linear fashion, from the beginning till the end, and searching for each and every value, you just know the location right away by applying the hash function. So that is what is the advantage of hashing. And now I'm going to show you hashing in practice. We're going to see with a very good example what a simple hashing looks like. Let's see a simple example of hashing. I'm going to take the keys that I showed you previously and going to insert them into the hash table. The size of my hash table is 10, like I said before, and I'm going to use a function which is a division function. A division function basically works in this way. If you pass a value to it, it is going to divide that value by using the size of the table. And then whatever is the remainder, that will be the index in which you will store that key. I'll explain that in a little bit, but you just need to understand first the basic concept of it, what a hash function is. And if you don't know what modulo is, this division function that I told you about is called modulo. So if you don't know what a modulo is, then I'll just give you a brief idea. A modulo function basically divides the number provided and instead of returning to you the quotient, it returns to you the remainder. So that's what modulo function does, and that's the function I'm going to use. The advantage of using this is the size of my table is 10. So if I use modulo 10 as a hash function, then I know that I'll be getting values only from 0 to 9. So it limits the number of values that I can get as an index, and that's why it forms a very good hash function. In practice, we use a better value of modulo. We don't use 10. We keep a table size that is essentially a prime number and a large number. We don't keep such a small size. But for practice purposes, I'm going to use this modulo 10, because when you do modulo 10, you will simply get the last digit of your number. So it's just very easy to understand. That's why. Okay, so let's start now by inserting some values inside this hash table. So let's say that I have a key 33. That was my previous number of keys that I showed you. So if I have a key 33, it is going to be divided by 10. That means not divided but modulo by 10. So 33 divided by 10, the remainder is 3. So 3 is my answer. That means I need to store 33 in index position 3. So let's go ahead and put it in index position 3. Okay, the next key that I'm going to insert is 45. So 45 modulo 10 gives me 5, which means I'm going to put 45 in position 5. The next key I'm going to insert is 56. 56 modulo 10 gives me 6. So I'm going to put 56 in position 6 right here. The next key I'm going to insert is 12. So 12 modulo 10 gives me 2. So let's go ahead and put 12 in position 2. And lastly, I have 19. This is the last key I'm inserting. So 19 modulo 10 gives me 9. So I'm going to put 19 in position 9 right here. And that's it. That's what hashing is in a nutshell. It's very simple and very effective. Now you can imagine that if I am looking for the value 19, I'm not going to start from the beginning of the table and start looking at each and every cell. I'm simply going to apply the hash function. So if somebody tells me to find 19 from my table, I'll just do modulo 10 and I'll get 9, and I know that 19 is in the 9th position. I don't have to go through the entire index in order to search for a particular value that I've stored in my hash table. So this is how hashing makes indices faster and more accessible.